Imagine yourself gazing up at the night sky. The stars twinkle like tiny, distant lights scattered across an endless void. But hidden in that cold and silent ocean of space, astronomers have just revealed a discovery that made the entire world sit up. Two planets, Gliese 1002b and Gliese 1002. So similar in size and conditions to Earth that they could almost be called its twins. And the most astonishing part, they're close enough for our modern technology to begin studying them in detail. This breakthrough came from years of careful observations, combining the power of several of the world's most advanced telescopes, including the James Webb Space Telescope, humanity's most sophisticated eye in orbit, by analyzing the tiny wobbles in the light of their parent star. Gliese 1000 to a faint but stable red dwarf, scientists detected the subtle presence of two hidden worlds. After thousands of measurements and simulations, they confirmed these aren't just ordinary planets. They are worlds with size, mass, and orbits strikingly similar to Earth's. What shook the scientific community even more was the distance. Most exoplanets we've discovered lie hundreds or even thousands of light years away, but Gliese 1002b and Gliese 1002c, they read just 16 light years from us, close enough for today's telescopes to start probing their atmospheres and surfaces, and close enough for researchers to dream of future missions that might one day explore them more directly. Even more exciting, both planets sit right inside the so-called habitable zone, the sweet spot around a star where temperatures could allow liquid water to exist, and where there is water, the chances of complex organic chemistry and perhaps even microbial life rise dramatically. In other words, Gliese 1002b and Gliese 1000c aren't just lifeless rocks drifting in space, they carry the potential to be true second Earths. For humanity, this discovery feels like a door creaking open to a whole new frontier. For centuries we've asked, are we alone in the universe? And now these two promising worlds seem to whisper back from the cosmic dark. Perhaps life isn't confined to our little blue planet after all. Now, imagine yourself aboard an imaginary starship, drifting silently in the vast darkness. Ahead of you, two strange new worlds slowly come into view. Gliese 1002b and Gliese 1002c. The first to reveal itself is Gliese 1002b compact, shimmering like a deep blue jewel suspended in the void. Its size and mass are almost a mirror of Earth's, not much bigger, not much smaller. If you could set foot there, the gravity beneath your boots would feel familiar, almost like walking back home. Simulations suggest that because this planet sits closer to its parent star, it receives just enough energy to sustain a warm climate. Scientists believe that if it has an atmosphere, it may be thick enough to trap that warmth, shielding the surface from harsh radiation. And hidden within that veil of gases, faint hints whisper of possible water vapor, raising the tantalizing hope of rolling oceans somewhere across its surface. Farther along its orbit emerges Gliese 1000c, the older sibling, slightly larger, cloaked in mystery. Observations suggest it may be wrapped in thick clouds or photochemical haze, a curtain that blocks the starlight and conceals whatever lies beneath. This world still sits within the habitable zone, but it hovers on the edge. It could be a warm planet with seas and skies, or just as easily a cold, hostile sphere, teetering beyond life's reach. What makes both of these worlds remarkable is their balance. Neither too close to their star to be scorched, nor too far to be frozen. Both dwell in the habitable zone, the delicate strip of orbit where liquid water can exist. And as you know, wherever there is water, there is always hope for life. Yet the big questions linger, suspended in the cosmic dark. Do these planets hide molten cores that generate protective magnetic fields? Do colossal volcanoes reshape their skies, recycling gases to keep the climate stable? For now, these are only theories, but it is precisely this mystery that makes Gliese 1002b and Gliese 1002c golden candidates in humanity's search for life beyond Earth. One world seems like a promising twin of Earth, the other, shrouded and enigmatic, tempts us with its dangerous allure, showing us how razor-thin the line can be between a cradle of life and a world just a fraction too harsh for anything to survive. The discovery of Gliese 1002b and Gliese 1000c is like stumbling upon two mysterious books in the vast library of the cosmos. Each planet is a page written in the language of stars, rocks, and atmospheres, and humanity is only just beginning to learn how to read those lines. For astronomers, this isn't just about adding to more dots of light on the star map. It's living proof that Earth is not the one and only exception. If right in our cosmic neighborhood circling a small and quiet star like Gliese 1002 there already exist two worlds with such promise, then across the Milky Way with its hundreds of billions of stars, the chances of countless other Earths out there are nearly certain. More importantly, these two worlds are natural laboratories. They allow humanity to test its boldest ideas about life itself. Gliese 100 to be warmer and closer to its star, where a thin atmosphere and traces of water vapor might exist, poses the question, is water plus a stable sky enough for life to take root? Meanwhile, Gliese 1002c farther away, cloaked in haze or even toxic gases, it forces us to ask, what exactly pushes a planet perched on the edge of habitability into a realm too hostile to sustain life? Imagine this: if one day telescopes detect both water vapor and methane on Gliese 1002b, that could be our first real hint of microbial life beyond Earth. But if Gliese 1002c turns out bone dry or smothered in poisonous gases, then that contrast itself becomes a parallel experiment, teaching us where the fragile boundary truly lies between livable and unlivable. From a scientific view, studying this pair of planets is like holding up a mirror to Earth. Placing them side by side with our own homeworld highlights what has kept Earth stable for billions of years: the shielding of its magnetic field, the recycling power of geological activity, the perfect balance of light and shadow from the sun. These comparisons, Dan T, just expand our knowledge. They remind us just how rare and precious Earth truly is. And beyond science, this discovery plants a deeper question, one both practical and philosophical. If there really is another home, could humanity ever set foot there? What would it mean to live beneath the sky of a foreign star, to walk upon alien soil? That's why Gliese 1002b and Gliese 1002c are not just bright points in the night sky. They are mirrors, one reflecting hope, the other challenge. And with every such discovery, humanity takes another step closer to answering the oldest question of all: are we truly alone in the universe? It sounds incredible, doesn't it? Two Earth-like planets, Gliese 1002b and Gliese 1002c, and they're even relatively close by, at least on the cosmic scale. But right behind that excitement comes a wall of enormous challenges, almost as if the universe is whispering, "You can see me, but that doesn't mean you can touch me." First, the distance. Even though these planets are only a few dozen light-years away, far closer than most exoplanets ever found, with the fastest spacecraft humanity has today, it would still take hundreds of thousands of years to get there. In other words, for now we can't send people, or even robotic probes, to Gliese 1002b or Gliese 1002c. At best, we can only peek from afar, catching faint signals of light through our telescopes. Second, the limits of our tools. Everything we know about their atmospheres or surfaces comes from analyzing the thin trickle of light that passes through. Imagine trying to guess what's behind a curtain just by looking at its faint shadow. Does Gliese 1002b hide vast oceans? Is Gliese 1002c shrouded in thick clouds or poisonous gases? For now, it's all speculation built on faint, indirect clues. Third, the host star Gliese 1002. It's a red dwarf, a type of star notorious for being temperamental red. Dwarfs are known to unleash violent flares that can strip away a planet's atmosphere in an instant. So even if Gliese 1002b and 1002c sit inside the habitable zone, that doesn't guarantee they're actually friendly places for life to survive long term. Fourth, the risk of misinterpretation. When telescopes pick up molecules like oxygen or methane in an atmosphere, it's tempting to shout life. But those gases can also come from purely geological or chemical processes with no biology involved. If we're not cautious, we could end up declaring the discovery of alien life when it's really just a scientific mirage. And finally, the biggest challenge of all, our own human limits. Yes, we've set foot on the moon. Yes, we've set foot on the moon. Yes, we've sent probes to the edge of the solar system. We are still in our infancy. Gliese 1002b and 1002c are like houses on the horizon, barely visible, while Earth remains the only cradle we truly have. Finding neighbors doesn't mean we can pack up and move in tomorrow. But here's the beauty of it. Those very limits make the journey more thrilling. Every obstacle is an invitation. Keep exploring, keep reaching further, and who knows? Technologies that sound like science fiction today, light sails, interstellar engines, might become reality in a few centuries, opening the path that brings us closer to Gliese 1002b and Gliese 1002c. If the discovery of Gliese 1002b and Gliese 1002c is like a door just cracked open, then the bigger question is, how will we step through it? Right now, humanity can T-fly there yet, but that doesn't mean we restuck just watching from afar. Even as we speak, massive projects are already underway. The James Webb Space Telescope, JWST, and the next generation of even more powerful observatories are acting like giant eyes in space, able to peer into the atmospheres of Gliese 1002b and 1002c, hunting for traces of water vapor, oxygen, or even the elusive biosignatures, indirect signs of life. Looking further ahead, ideas that once lived only in science fiction are slowly becoming real plans. Take Breakthrough Starshot, for example, a bold international initiative aiming to send tiny light-powered sails, pushed by lasers, racing through space at a fraction of the speed of light. If it works, we might receive close-up images of nearby star systems within just a few decades. And who knows, Gliese 1002b or Gliese 1002c could very well be among the first targets. But with that future come bigger questions. If we discover life, what should we do? Reach out, or simply observe from a distance? If a planet proves habitable, will humanity plan to settle there or treat it as nothing more than a friendly neighbor in the vastness of the cosmos? And perhaps most importantly, are we truly ready to become an interplanetary civilization? What's fascinating is that every step toward Gliese 1002b and 1002c also makes us look back at Earth more clearly. When we realize how fragile an atmosphere can be, or how rare liquid water really is, we begin to see just how priceless our blue home is. The universe may hold countless second Earths, but before dreaming of them, maybe we need to learn how to take better care of the one we already have. Now imagine a few centuries from today, our descendants might sit in front of screens, not to squint at faint telescope data, but to admire crisp, vivid photos of seas, mountains, and skies from another world. Perhaps they'll tell each other the story, long ago. Our ancestors first discovered Gliese 1002b and Gliese 1002c, and that S when the dream of reaching the stars began. The cosmos is still wide open, and our journey has only just begun. Gliese 1002b and Gliese 1002c may never become our future homes, but they've already done something just as powerful. They've lit the fire of exploration, a fire that could carry us further than any dream we've ever had. So what do you think? Will humanity one day truly find life out there, or even set foot on a brand new world? Share your thoughts in the comments. Who knows, maybe your perspective will open up a new way of looking at the stars. And if you enjoyed this video, don't forget to like, share, and subscribe so you won't miss the next adventure with us across the endless universe.